Now, this will be the last video of our school year and our time together, and I know, that makes me really sad as well. But I thought it'd be cool to finish our time together and all the progress we made so far in math by finishing with something that's kind of fun, which granted I know is a pretty relative term in math. But this is a pretty fun concept. I know my 8th graders last year had a lot of fun with this, and I also know that this is something that you must see and you must be at least familiar with before you move on to high school. Now, this cool and relatively fun topic is something called the Pythagorean Theorem, which I will write down right here. This is really cool because it tells us exactly how the sides of a right triangle are related. Now, these two triangles that I have right here are something called right triangles, and I'll be writing that down right now. The reason why I know they're right triangles is because I see that there is an angle in each of the two triangles that is 90 degrees. How do I know it's 90 degrees? I know it's 90 degrees because it is a square. The square means that it's 90 degrees, and that tells us that that means that that triangle is a right triangle, which both of these two are. I know they look different, but because it's a 90-degree angle, these are right triangles. Now, the right triangles are really important because they also have specific names for each of the sides. Specifically, there's this one side that's really important. It is across from the right angle, so I'm going to draw this arrow right here, and it's something called the hypotenuse. Once again, it's called the hypotenuse. We know that number 1, it is always the longest side, and number 2, we know it's also always across from the right angle, the 90-degree angle. So if you want to find the longest side, just look across the right angle. Now, what are the other two sides called? Well, these sides have a much more boring name. They're just called legs. So each of them are called legs. They're indistinguishable from each other. So we call both of them legs. Whatever is not a hypotenuse basically is a leg. You can see this in the exact same way in the other triangle as well. The hypotenuse is the longest side. It's across from the right angle. And the two other sides are just called legs, just as we've seen before. Now, I might ask you this. So if I had a right triangle, the sides are 3, 4, and 5, I would ask you, which ones are the legs and which one is the hypotenuse? How would I be able to find that? Well, I look at this right triangle and I notice that there's only one side that number 1 is the longest side, but also number 2 is the side that's directly across from the right angle. I know as a result that that is my hypotenuse. It's 5. In contrast, as a result, the other two sides become my legs, and that's 3 and 4. So this is a pretty straightforward question that as long as you understand what the hypotenuse is and what the legs are, you should be fine. But there's a more interesting thing going on here. And let's look at these sides. We have 3, 4, and 5. What if I told you that these sides are actually related to each other? What if I told you that if I found a square of each of the two legs, I could find a square of the hypotenuse? What if I did 3 squared plus 4 squared? If I squared each of the two legs, what would I get? What if I told you that's equal to 5 squared? So for example, 3 to the power 2 is 9, 4 to the power 2 is 16. I add 9 and 16 together, and I get 25. What's going on here? Let's look at this a little bit more carefully. It turns out that with the Pythagorean Theorem, this always happens. If I call the two legs A and B, and then I call the hypotenuse C, what I know then is that A squared plus B squared is always, once again, it's always equal to C squared. So put another way, if I squared each of the two legs of this right triangle, so each of the two shorter sides, and I added the two squares together, I would always get the square of the hypotenuse. A squared plus B squared is equal to C squared. This is a very, very important equation that you'll see again and again. It's also something that's really good to memorize. Let's dive into what exactly this means in practice. Let's test this with another example. Let's say, for example, we have a right triangle with legs 5 and 12 and this hypotenuse 13. Let's see if this works. The question is 5 squared plus 12 squared equal to 13 squared? How would we know? Well, we know how to square. We can just square it out, right? So we have, for example, 25, because that's 5 to the power of 2, plus 144, because that's 12 to the power of 2. Remember, 5 times 5 is 25. 12 times 12 is 144. If we add it together, that's 169. Now, the question then becomes, is this right side of the equation on both sides? So is 13 squared equal to 169? Are these two the same? Let's dive into what exactly that means. Well, we know that 13 times 13 is 169. So as a result, that leads us to know that 13 squared is equal to 169. And so as a result, the Pythagorean theorem works in this case just as it works in every case involving right triangles. Now, what's really important is that this only works for right triangles, so don't try to do this with triangles that do not have a 90-degree angle. Let's look at some other ways that we can use this theorem. Let's take another right triangle. Let's say, for example, we have a leg of 2, a leg of 3, and a hypotenuse of, well, you know what? I'm actually not going to give this to you. You might be wondering, can you use the Pythagorean theorem to find missing sides? And the answer is actually yes, you can. If you have two sides, you can find a third side quite easily. Let me show you how. You can do this by setting up the Pythagorean theorem equation just as we did before. So 2 squared plus 3 squared, because 2 and 3 are the legs. What is that equal to? Well, we know that that's equal to the hypotenuse squared. We don't know what the hypotenuse is, so you know what? Let's just call it C. Let's call it C because that's what the letter is in the original equation. You can call it whatever letter you want, but I'm going to choose C. 2 squared plus 3 squared is equal to C squared. 2 squared is 4. 3 squared is 9. And 4 plus 9 is equal to C squared. So what do we do next? Well, then we know that 4 plus 9 is 13, and 13 is equal to C squared. So how will we find C? Well, we have a friend called the square root, right? We know that we can reverse squares by doing a square root. So root 13 is equal to root C squared. Root C squared is equal to C. So C is equal to root 13. Now this point might be a little confusing to some of you. Basically, if you square something and you find that number, you can square root that number to get the original. The square and the square root are opposites in this case. So as a result, this gives us root 13. Now some of you might also be wondering, wait, I thought the square roots have a negative and a positive. You're absolutely right. Square roots do have a negative and positive. But in this case right here, we're only going to take the principal square root, so the positive square root, because we're working here with distances, with lengths, and distances and lengths are always positive. If you had that question, that's a great question, but the answer to that is that it's always positive. We're only taking the positive square root. Now let me show you a common mistake that I might see people making. Let's say, for example, we have 5 as a hypotenuse, 4 as a leg, and let's call another leg A. Now, the mistake that I see a lot of people making is I see them saying 5 squared plus 4 squared is equal to A squared. Why would that be wrong? Well, that'll be wrong because A is not the hypotenuse. A is the leg here. So the correct equation actually is A squared plus 4 squared is equal to 5 squared. Now, setting up the equation is the hard part. After that is very easy. But what's really tough is that I see a lot of students get this part incorrect because they see a missing side length and they always think, oh, the missing side length is always hypotenuse. And that's not the case. That's actually how they trick you sometimes. So it's really important that you know exactly which one the hypotenuse is and which one the leg is. That's why I spent a lot of time on it earlier. So we have A squared plus 4 squared is equal to 5 squared. We know then that's equal to A squared plus 16 is equal to 25. Because we know that 4 squared is 16 and 5 squared is 25. And after that, what do we do next? Well, we want to isolate A squared, right? We want to put A squared by itself. So what we can do is we can subtract 16 on both sides. After we subtract 16 on both sides, we have A squared by itself on the left. So A squared is equal to 16 minus 16, 0, so I don't write that at all. And 25 minus 16, what would that be equal to? Well, that is 9. So after we find A squared is equal to 9, we can then do the following. We can find root A squared, that's equal to root 9, and which gives us A is equal to 3, because square root of 9 is 3. 3 to the power of 2 is equal to 9. So some of you might recognize this from earlier. This is the exact same triangle that we saw earlier, with the two legs 3 and 4, and the hypotenuse is 5. We're basically coming back to square one. Now that's really important to me because we're actually coming back to square one with a lot of what we studied so far. You studied exponents, you studied square roots. You notice how both of these things are really important for this final chapter where we are studying the Pythagorean Theorem. So this is one really cool way in which all the math that we studied so far comes together to form part of the same story. Now, it does make me really sad that I will not be teaching you next year as you all move on to high school, but I know that you all are very capable. I've seen a lot of you grow, I've seen a lot of you succeed, I've seen a lot of you push yourself. And I just want to let you know that I'm just really proud of you. I'm really happy I got the chance to learn from you and to learn with you and to help you learn as well. Until the next time we see each other, I hope you're taking care of yourself, I hope you're staying safe, and until next time. Thank you so much for showing the love to Kim Academy.
Colors, they die into gray.